In this podcast, I will be showing how to convert binary numbers to decimal and decimal numbers to binary. Also how to carry out bitwise AND operations using the class exercises. Here is our first binary number where all are turned on 1, just to make it easier so I can show you the place values. We read from right to left. The first position is referred to as 0, 2 to the power of 0, and the value is 1. The second one is referred to as 2 to the position 1, 2 to the power of 1, and this is 2, 2 to the power of 2, which is 4, and up to 2 to the power of 7, which is 128. And most people know these numbers easy enough. Maybe the last one, if you're not sure, just try to remember that, 64 and 128. It's easy ones. Rather than having to enter them into the calculator and find the values, it's easier if you remember them. And here's an actual number that's given in the exercise, and we're going to convert that into decimal. So first we look at which numbers are turned on, which means 1, off means 0. So these two numbers are turned on, therefore we write the values for those two numbers, but the next one is off, so we enter 0 for that. Or we can just not bother to enter anything. If you are, just remember to enter only the values for that are turned on. So there's the 8 because that's the 2 to the power of 3, and there's 64 for the 7th position, which is 2 to the power of 6. If you are likely to make a mistake, most likely I think is when you get, if you forget that this is a 6 instead of a 7, because this is the 7th position and this is the 8th position, it's 2 to the power of 7. So just be careful not to do that. If you remember these numbers, you don't have to worry about calculating these 2 to the power of. You just know that number is easy enough and it's quick, it's done. So in this case, we forget the ones that are turned off and add up those that are turned on. So 128 plus 64 plus 8 plus 2 plus 1 gives 203. And the next number, we have 4 turned on again, and these 4 are 32, 16, 4 and 1. Notice the position. It's important you get the position right. It's so easy to make a mistake in this. If you get that one wrong, just don't lose easy marks, okay? And these numbers add up to 53. And the last one is, we have 128, okay, because it's the 8th bit that's on, which is 2 to the power of 7, and then the first two, which is 2 and 1, that's an easy addition. There you go, you got 131. And the next one we are going to do is convert now the decimal numbers into binary. So to do this, we keep dividing the decimal number by 2 and record the remainder each time until the final answer goes to 0. When we say divide, when we say carry out integer division, this means, when, for example, if I ask you what is 5 divided by 2 using integer division, answer will be 2 rather than 2.5. If it's a decimal answer, we will give you the 2.5 with the decimal place. But now with the integer division, we just ask how many times does 2 go into that number. How many times does 2 go into 213? 106 times with a remainder of 1. So we write the remainder on the right side. Then we ask the next one, how many times does 2 go into 106? 53 times with a remainder of 0. How many times does 2 go into 53? 26 times with a remainder of 1. How many times does 2 go into 26? 13 times with a remainder of 0. And so on. We carry on the same division and remainder, except what might be a little bit tricky is when you come to this one. How many times does 2 go into 1? How many times does 2 go into 1? Does it go into 1? It cannot. So therefore it goes in 0 times and with a remainder of 1. This sounds tricky because let's say you have one item and you want to divide it among 2 people and you cannot divide it among 2 people equally. What are you left with? You're still left with 1. So kind of think of it like that. That's the remainder of 1. So if the number that you're dividing by is bigger than the number that you're dividing, then the remainder will be the number that you're dividing. Okay, so 1 divided by 2, the remainder is 1. And how many times does 2 go into 1? 0 times. So now when you get these answers, you write it from top to bottom, you enter it here. When you enter this, you will be having the binary number for 213. Okay, just make sure you enter in the order given. Okay, and from top to bottom is left to right. That's crucial, otherwise it's a mess, wrong value. So for number 9, for example, it's how many times does 2 go into 9? 4 times with a remainder of 1. So we carry this on until we come to the last one when the value is 0. There's no more division to do, and fill the rest with 0. Okay, so therefore the answer is this. Now usually if you see a binary number given just like 1001, remember it's going from right to left and fill the remaining bits with zeros in the front, not at the end. So you might just come up to here and you will get the answer, but remember to fill these with zeros. The next number we can do together, 67. 67, how many times does 2 go into 67? So we enter here 33, and the remainder of 1, how many times does 2 go into 33? 16 times with the remainder of 1. How many times does 2 go into 16? 8 times with the remainder of 0. How many times does 2 go into 4? Sorry, 2 go into 8? 4 times with the remainder of 0. How many times does 2 go into 4? 2 times with the remainder of 0. How many times does 2 go into 2? 1 times with the remainder of 0. Now comes the last one. How many times does 2 go into 1? 0 times with a remainder of 1, because you cannot divide 1 by 2, therefore 1 just remains, and here's your answer. Okay, so you've got, remember writing the answer from top to bottom? There's the answer, top to bottom. Okay, 0 1 0 0 0. Okay, the next one that we are going to do is carry out bitwise AND. Now in the original question, if you don't mind, please correct that question. It actually says adding the following binary numbers. It should be ANDing, because if you're adding binary numbers, you get a different answer to what you would get if you were ANDing them. To AND them, it means carry out the bitwise binary operator AND, which means 0 and 0 is a 0. Just remember this rule, that a Boolean logic says when you AND 2 bits, it would result in a 0 always result in a 0, except when both the bits are 1. Always 0 except when both bits are 1. Okay, you would have done this in programming. So in this case, 1 and 1 is the only one that gives a 1, otherwise it's all 0. So if you just remember that, you can do the binary ANDing or bitwise ANDing. So here it is. Let's do the first 2 numbers. Whenever you get this, if you think that, like, obviously you can just add these across, but I've just written it easier to see. So in this case, how many numbers have, how many, what do you call, places have both numbers being turned on? This is only 1 here and 1 here. All the rest are 0 1 or 0 0 or 1 0. Remember the rule? All the time the result will be 0 except if both the bits are 1. So if you just remember that rule, you can simply enter 0 for all the rest. Okay, and so here's the answer. And then it says give the answer in decimal as well, and now you are experts in converting. So simply remember, where all zeros, you enter zeros, or you don't bother entering anything. Simply just pick the value that is a 1 and add that number with another one that is a 1. Okay, so 120 plus 2, decimal number is 130. So the next one also you can do it the same way, but I think I might be running out of time. Oh no, I've got, yeah, I might be running out of time, but it's almost done. Okay, so this one is 0 0 0 0 0 0 0, except for this one, it's a 1. What's the rule again? For and it's all